Few years back, everyone wanted AI GPUs. Companies bought them like they were the last bottles before the storm.
Blackwell sales are off the charts and cloud GPUs are sold out.
Growing even faster than the GPU market over the next few years.
Nvidia, they're looking to sell the entire system, not just the chip.
And now, a recent 2026 Kubernetes optimization report says the average GPU utilization across the analyzed cluster was just 5%. CPU utilization was 8%. Memory was 20%. That's insane because GPU are not some cheap background workers. They are the VIP section of computing. And according to the same reporting, organizations are paying for roughly 20 times more GPU capacity than their workloads. So what happened? Why did AI companies rush to buy GPUs? Why were GPUs so important? And now those expensive hardware are just sitting there. This is the dirty secret of this AI infrastructure boom. To understand the waste, first you have to understand the hype. GPUs became the center of the AI boom because they are really good at doing lots of math in parallel. Nvidia explains it pretty clearly. GPUs matter for AI because they use parallel processing.
The researchers took a GPU and said, I'm going to hack it to get it to expose the parallel computation capabilities to unlock that performance for the deep learning use case.
Actually, that makes sense. Because CPU is like a smart employee that does one task at a time. But the GPU is like a group of interns that do multiple small stuff at the same time. For AI, especially training and inference, parallelism is a goal. It's everything. That is why GPU was considered like a rare material in this AI era. Nvidia called it even a foundation of the new gen of AI. So if you are a company from 2025 and 2026, everybody is screaming like AI is everything, AI is the future, inference is exploding, build now or fall behind. Then GPU stop looking like a hardware. It feels like it's a survival tool. This part is important. The buying spree was not irrational at all. McKinsey says that by 2030, data centers may need $6.7 trillion in capital expenditure to keep up with the compute demand. And $5.2 trillion of that is projected for AI processing loads. That is not a niche trend. That's a global arm race. And when companies see these numbers, they don't wait and see. They try to conquer it. Business Insider claimed this quite bluntly that AI companies are buying GPU just because of FOMO. And honestly, that checks out. Because if you're a CEO, tech lead, or some leading architect, and somebody keeps on you asking what's your AI strategy for this week, buying a GPU is a safer answer than saying we will wait until we actually know what we need. That answer doesn't survive the board meetings. So the motive was a mix of fear of missing the AI wave, fear of future GPU shortages, pressure from leadership, and pressure from competitors, and the belief that if you don't secure it now, you won't get it later. That part is real. Here is the uncomfortable part. Buying a GPU is a lot easier than using it. A lot easier. The Cast AI report says that analyzed cluster averaged 5% GPU utilization, and they frame this as a growing efficiency problem, and there are a few reasons for that. They bought for a peak demand. AI workloads are always not steady. They might need a computing power for model run, a fine-tuning experiment, a batch inference job, a demo for leadership that somehow became urgent 40 minutes ago. And then after that spike, nothing. So companies provision for that one scariest day or the scariest moment, not for the average day. Result? Expensive hardware lying around doing nothing. The second reason is GPU orchestration is really messy. Kubernetes is very mature for normal computing, but GPU are completely different. Now you're dealing with expensive instance type, scheduling constraints, driver issues, sharing and partitioning problems, queuing, right sizing, and all the fun of getting high utilization on hardware that costs dollars per hour when idle. Reason number third is AI demand is still immature. Many companies bought GPUs before the actual mature demand. They have pilots, they have AI demos, they have one chatbot, they have 3 teams exploring agentic workflows. What they do not have always is the real demand to keep those GPU fleets busy. This mismatch is the huge part of the story. Here is why things get spicy. GPU idle is really annoying. Idle GPU is expensive enough to make the financial guy blink harder. Cast AI's report puts it really clearly. An idle GPU costs around $1 per hour, but the idle CPU costs only 5 cents per hour. It also quotes that 95% of GPU is doing nothing in the measured baseline, because this is not the little inefficiency. Here the company are paying for the scarce infrastructure that they are not going to use at all. TechRadar's write-up of the report says organizations are paying for roughly 20 times more GPU capacity than actually needed, and adds that CPU utilization fell to 8% while memory dropped from 23% to 20%. That is not optimization, that is expensive panic. This part is almost funny because many companies buy GPU often out of scarcity, but when everyone hoards GPU, the price goes up. Then they get panicked even more, and they hoard even more. TechRadar's reporting on the same dataset notes that this hoarding instinct makes sense because lead times are long, but it also fits the scarcity loop that pushes prices higher. So you get this beautiful enterprise cycle. We bought too much because we were scared. The price is going high because we bought too much. So naturally now we should buy even more. This is where you should be fear. The 5% usage is strong, but it doesn't mean that every company in the world just uses 5% of GPU. The Cast AI press release says the report is based on tens of thousands of clusters and specifically reflects non-optimized Kubernetes cluster. TechRadar also notes that not every cluster performed this badly, and that one organization reportedly hit 59% utilization on Edge 200s and 30% on Edge 100s, far above the average. This is not the proof that all AI companies are clueless. It is proof that poor GPU usage is common enough to be a serious industry problem, and that is still a huge story. Right now, the AI infrastructure is going through a shift. The first phase was get GPUs at all cost. The second phase is how do we stop burning the money? That's a real transition. AI-related data center investment alone could hit $5.2 trillion by 2030 in its best scenario. At the same time, the Cast AI data suggests a lot of enterprises' Kubernetes environments are still nowhere near efficient. So the market is going from GPU acquisition to GPU efficiency. And honestly, that might be a real competitive edge, because in the next phase, the companies who bought so much of GPUs are not the real winner. It may be the company that keeps the GPUs really busy. So why did companies buy all the GPUs? Because GPU are really good at doing parallel stuff, doing the parallel math, and it's really good for AI workloads, AI inference. But why did they buy so many? Because in AI generation, in this AI era, computing felt necessary. GPUs felt like it is the rare material in this AI era, and it felt like it will finish the next day. It is the last bottle of the year in the scarcity. So they buy them, they collected them. What is going on right now? Many companies realize that owning a hardware and using the hardware efficiently are completely two different things. And the report also says that average GPU utilization is around 5%, and it stays there all the time without being used. And the idle time in GPU is also really expensive. So the dirty secret of AI infrastructure, AI generation is the gold rush was real, but most of the gold are lying in the warehouse. So that's all for this video. I hope you liked the content. You are watching Subhash Shrestha at Arconsis, and I hope to see you in the next video. Thank you very much for watching.